Hi, everybody. Welcome to another Future Tech podcast series. It's myself, Charlie Sell, the MD of Arrows Group. This podcast series is focused on STEM graduates, looking at interviewing CTOs, CIOs, senior execs across the entire technology space, asking them their thoughts, their story, ideas, and advice for the STEM graduates of the universities we're paired with. So it gives me great pleasure to have Pierre Martin with me today. He's the CTO at Beacon. Beacon is a supply chain technology business, a startup business in London. Anyone who's seen the papers would have known it's been seriously backed by some quite impressive people. It's up to, over to Pierre to give us a bit of a story. So hi, Pierre. Welcome to the show.
Hi, Charlie. Thank you for having me. Real pleasure and happy to share some insights and lessons learned with the people here.
Yeah, fantastic. And I should say that you're calling. We're on a VC in France, aren't we? You're on actually holiday, so this is really good of you.
Well, thank you very much. Yeah, well, love to spend time talking about my journey and I think that can help students and people who are interested in learning more about STEM.
Fantastic. So, let's dive straight into it then, and tell us a little bit more about who Beacon are, and then a bit about your story.
Great. Well, to start with, Beacon, as you said, is a supply chain technology startup in London. We're actually a new type of supply chain service, really, so to speak, which combines multimodal logistics with fintech, data science, and a software as a service platform. And it is actually built and designed to help businesses improve their supply chain, meaning making it more efficient, more cost-effective, more reliable, and very importantly to me, more sustainable over the long term. So we're, as you said, a Series A stage company. We're not even 2 years old, but have about 60 employees at this point in time. And as you said, backed by serious investors, so personal investment from Amazon CEO Jeff Bezos, but also Google's former CEO Eric Schmidt, Uber's co-founder, and VC in Silicon Valley in Europe, including 8VC, Expan, and Neo, among many others.
Fantastic! Wow, yeah, and I mean, you have a background with Amazon yourself, don't you? So your story would be quite interesting.
Absolutely. So before Beacon, I spent 5.5 years at Amazon, and before that, another 5 years at Microsoft. And in fact, Beacon is my first startup, so to speak. Although there's been a few false starts in the past, and I'm happy to speak about that also. I think I probably had a more traditional path in computer science. So I did study engineering here in France, in fact, and then got actually I tried to stay in university as long as I possibly could. So I ended up getting a doctorate in computer engineering from one of the big public universities in the United States. And worked actually on my doctorate for a few years at a very interesting field at the intersection of quantum physics and computer science, which was not quantum computing, but in fact I was spending a lot of time researching algorithms that simulate what happens at the atomic scale in very small devices.
Wow.
And it was a very interesting time for me because it was at the intersection between computer and device architecture, so very physical, silicon-based research and development, but also computer science. And I remember I had this clear bifurcation in my career where I thought, well, do I want to be more of a silicon type of engineer or a software engineer? And I realized in the process of doing what I was doing, I was developing quite a few important skills for my later career as a computer scientist. So it was, building, I was spending time, designing efficient algorithms that can process large amounts of data at scale in a cloud environment, in a distributed environment, in parallel. And that's where I realized, I can either try to follow Moore's law on the silicon level, or I can try to make, software more efficient. And this is what ultimately led me to Microsoft Research to start my career. And then into some big commercial products like Xbox and later on Amazon.
Yeah, wow.
And maybe to finish my story, I think Amazon was interesting for me because I think it's the first time I really tackled very deep algorithmic problems. So I spent 5 years at Amazon building the software that computes how Amazon moves freight and packages worldwide. So we're talking billions and billions of packages that need to be optimized, and I really enjoyed it. I think I didn't realize logistics had so much to offer to computer scientists. There's a lot of very deep problems to solve, especially at scale. And that's also where I grew as a technical leader, and then an engineering manager, at the end head of engineering for a team at Amazon. And I knew that logistics was also at that phase where it's just getting started. I think Amazon is, of course, the gold standard and at the forefront of what optimal logistics and supply chain can be, but also realizing that 99% of other retailers and businesses don't have access to that type of refinement, and I felt passionate to develop computer science in that field, and therefore joined Beacon almost 2 years ago now.
So fantastic. So what was the transition like from Microsoft to Amazon? So from going from one PLC to another, was there big cultural differences or anything that you learned along that way?
Oh, yeah, great question. I think there's differences, of course. There's a lot of similarities.
Yeah.
Well, even starting with their home base in Seattle, which is where I lived for more than 10 years. The approach to technology is a bit different, and I think what I find interesting at Microsoft was more the platform approach, and try to, of course, that's coming from Windows and the big cloud-driven businesses that Microsoft has. While Amazon was a lot more consumer and customer-driven, right? So I think Amazon brought a lot of the thinking about understanding what the customer wants, but also iterating very fast with the customer. So I think one of the things I really retain from Amazon's culture is it's okay to fail, actually, and it's encouraged to fail if it helps you go fast. And it's totally okay to release consumer products that are not working, as long as you learn something in the process. And I think, well, at my time at Microsoft, it was not the case. I think Microsoft also changed culturally quite a bit since I left more than 8 years ago.
Yeah, yeah. Well, and that's the other thing, isn't it? It's amazing how companies evolve, and even cultures can evolve, even in the PLCs, when multinationals based on trends and different economic factors. But I guess what would be really interesting is thinking from going from Amazon to Beacon, and when you're literally, it sounds like one of the first people to join. Yeah. How did that transition go? What were the pros and challenges behind that?
Yeah, there's many lessons learned. One, probably I'd love to tell all the students listening to us, or the future or recent graduates, is that it's okay, and I would encourage everyone to put yourself out there and try new things, and that's really how Beacon happened. And I told you there was a couple of false starts in my startup career where I really thought I was going to start a company, but I didn't. And I learned something in the process. One of them was you gotta have a good combination of technical talents, but also business acumen and investors. And if you don't have the three, something is going to be very hard in your journey as a startup.
Yeah.
So I almost joined a few startups in the past, which were technologically exceptionally advanced, but I couldn't convince myself that the business was there, and ultimately that's why I didn't do it. But also I ended up, right before joining Beacon, I ended up pitching an idea of a startup in fintech, which is what led me to London ultimately. And this is where I met my co-founder and now CEO of Beacon, Fraser, who had already started Beacon with his co-founder Dimitri at the time, and was pitching a fintech business, and a little after pitching this, Fraser just called me and said, I'm also starting a business and your idea is not bad, but I think mine is better. You should join. That's not probably literally not the same words, but something along those lines. And it was very clear that Beacon had that real good combination of good I would say balance in the team between technical strength and business acumen. Very strong investors. The business plan made sense.
Yeah.
And technology had a key role to play in there. So that's where I decided to join Beacon.
Yeah, fantastic. So then moving on to thinking about the emerging technologies, because it's clear, I mean, from what you must have seen, Microsoft, Amazon, and obviously your passion for technology, and it sounds like data science as well. What is your thoughts when you're looking at the roadmap, the strategic roadmap for Beacon, but also the wider market? Where do you see the future technology moving to?
Yeah, that's a good question. Well, I'm sure you're getting the same answer or an answer along the same lines from many people. Of course, machine learning and data technologies, including artificial intelligence, are undeniably something big happening these days. And where is it going? You hear about the human being removed from the picture and everything fully automated. I don't think this is where it's going. I think it's more along the lines of machine augmented human. I think that is the type of things we'll see happen over the next 5 or 10 years, and are already happening. And if you look at AI specifically, it's of course very good at automating tasks that are digitally native, right? Like classifying pictures, determining what's in a video or music, and doing signal processing. Of course, it's going to, and it's already surpassed human by many orders of magnitude. But the world is still very much physical, and I think it's also, if you look at the world, generally speaking, is very much an uncontrolled environment, which makes it very hard for machines to make good judgment calls and react to things that are not seen before in an efficient way. And one area that I think is very, very interesting is the area of deep reinforcement learning.
All right.
Not only because it's a way to design some AIs, but what I retain, it's been by having this fully unsupervised way of learning, and algorithms discovering an environment and building their own interpretation of an environment on their own, and actually learning on their own what are the best strategies to follow. It's been an interesting way for actually humans to discover new strategies that they can incorporate in their work, in their what they work on, generally speaking. So a good example of that, for instance, you may remember all this press a few years back about AlphaGo beating the best Go players on the planet, and I think just before that did the same at chess. So of course we can retain that some machines can become better than human and can automate what humans do. In reality, what happened is the machine, because it learned on its own, discovered new strategies for these games that professional players incorporated in their game. So in a way, I see it very much as human augmented machine or human augmented knowledge by a machine. Which is great, and I think that's an area I would love to see develop more in the future.
Yeah, that's really interesting. And so, with me being slightly less technical, what we're saying then is humans learning from machines and machines then learning from humans. So it's almost like a never-ending scale cycle.
That's right.
Of learning and further development, rather than one day machines taking over the development languages and human interaction becoming obsolete.
And applying that to logistics, can a machine fully operate a supply chain? Of course not, right? I mean, there's very physical aspects of moving freight, for instance, yet actually provably humans are better at handling shapes of random random shapes than robots. Yeah. But also the environment is very uncontrolled, right? So you have spikes in demand, and the market varies quite a bit. Now, can you run historical data through algorithms that will find possibly better strategies that historically we'd known? Yes, of course. Right? And I think that's where in supply chain specifically, we can use this type of algorithms and data science to derive better knowledge, more efficiency in the supply chain.
Yeah. And, you mentioned, the podcast series has been going for a little while now, and you're right that AI is quite a hot topic. A few people have talked to me a bit about trust and security around data, and that being, that equally has to advance as much as AI and VR.
Yes.
What's your thoughts around the trust and the security side of technology, and where there may be future job roles?
Yes, very much. In fact, I think it's a fascinating area of human machine interaction and interface design that's really emerging in the recent years to build trust, right? Like as you use a computer program, simply put, how do you trust that the algorithm came up with something that's trustworthy? Yeah. There's very funny things that even at Beacon we recognized and was recognized in the travel industry before. When we're computing prices or what is the most efficient way to ship or move freight, our initial implementation was very effective. Actually, it was computing in milliseconds. And so the initial response of our users in the test phase was, well, that can't be, right? Like you're cheating me. You're actually you're not doing any math. Like you're just spitting out results that were pre-computed, which was not the case. And so we had to introduce some delay just to make people believe that something was happening, right? Like there's real computation, and it was completely artificial. That's one of the examples of designing good human machine interfaces and interactions that build trust between the human and the machine or the algorithm.
Yeah. Well, that's a great one, isn't it? That you actually had to delay some of the speed of the software to create that perception of actual manual thinking. It's
yes, yeah. And security, of course, is very, very important, right? Like so many of these technologies rely on a lot of data. So of course you have to build trust with your customers that data is safe with you. Data security, not only from data classification, but encryption and making sure that networking is safe as well in very much distributed systems and on the cloud. Is an area, of course, I would strongly advise everyone to at least learn about to be more efficient in today's world and understand what are the trade-offs you can make and what trade-offs are not acceptable for security.
Yeah, brilliant. So thinking then, advice for our listeners. So thinking about when you were finishing at university and looking and navel gazing at where future job roles would be. What words of wisdom or pearls of advice have you got for STEM graduates today?
Many. I would say the first one is learn to learn. I think is probably the one I would always repeat. Technologies are just evolving very, very quickly. And I think, if I look at what was hot when I was a student, 12 years ago, it's definitely not even a portion of what you would see in the technical journals this day.
Yeah.
And I think being able though to recognize new technologies and absorb information, learn from them, and kind of experiment with these technologies is really the core skill here. And the great news is, programming has become much easier. So it's much more convenient these days to just spin up a small prototype, including machine learning packages and do some prototyping with data. than it would have been many years ago.
Yeah.
So I would strongly encourage anyone to just carve out time in your day to learn and to experiment and prototype with things so you can keep up with what's going on.
Yeah.
I would say, and connected to learning, I think curiosity is also probably the one thing I would advise everyone to be proactive about. And by curiosity, I mean trying to break the black box, trying to understand how things work, not in your direct line of work or industry, but sometimes outside of your industry. And I'll give you a few examples. For instance, in logistics, a lot of the patterns that you see are patterns that arise in other industries as well, right? So, for instance, scheduling problems around picking up and delivering packages, capacity allocation, like how do you distribute a mass of freight and packages to finite resources like delivery vans and things like that, have a lot of similarities with class of algorithms you find in in compilers and designing scheduling and capacity allocation in compilers. So understanding how these things work and how they can apply to other industries is really a good source of innovation. So being curious about the world and technology around you and understanding how it works is a very good way to maybe think more innovatively in your own line of work. Yeah. I would say just learn and be curious is probably a very important thing for any engineer and STEM graduates.
Yeah.
Maybe my last advice would be, spend time on the fundamentals. Cloud computing and data is here, of course, to stay. And as I told you, it's very easy to write a prototype, and it's probably 5% of the time to get something functionally working in one case. But the hard work is to make it a production system, right? A real product that's being used by users. And 95% of the work is just sweat and repetitive work, and it's understanding, deployments, continuous integration, continuous deployment, testing, writing maintainable codes, the type of things that some people may consider less fun, but this is such a critical skill in your career to be able to build production level systems. And I think don't discount that. You may be the smartest computer scientist, very good at math and excellent at writing efficient algorithms. If you don't understand how to bring those to production, then it's just research. It's not building products.
Yeah, and that last point I think is really prevalent, isn't it? The switch from academia, from understanding the research or the theory through to actually how to deliver something, put it through to production, and almost the street smarts even of what you need to do to get things live. It's fascinating in its own topic. So, well, Pierre, thank you. Well, that was really interesting. It's great to see someone who has seen both sides of the coin now, from the multinational through to startups and the lessons you've learned there. And again, I couldn't agree with you more around the learn to learn, not being afraid to fail. And it's great that Amazon sort of underpinned that for you as well. That's a lovely thing to hear. And then, yeah, the ability for any graduate to be able to turn theory into practicality and learn the fundamentals. 3 really good points there. So, yeah, thank you for your time, Pierre.
And I couldn't stress more the just don't be afraid to fail. I think anyone can do it, and if you believe you can do it, that's half of the job done.
Yeah.
But if you don't, you'll never try to build and create anything. So I think that's maybe lesson number 1 is don't be afraid to experiment and fail. That's how you'll learn how to do it the right way the next time.
And that's great to hear that from someone like yourself who's done so well. That really should be the mindset from across all levels, shouldn't it? Whether you are running a business all the way through to starting your career. So, thank you. Well, look, that's another episode of the Future Tech podcast series. It's going to be on YouTube, Spotify, and the career pages of all the universities that we're pairing up with. Once again, a big thank you to Pierre from Beacon.
Thank you, Charlie.
And to the next episode. So goodbye all.